Hey guys, this is Steven from Legit Tech Tutorials and the Green Engineers. Sorry about this. This is really late on Friday night, right before I'm heading to Hawaii tomorrow morning. Finally got packed, so I am ready to go. So I wanted to do a quick video, as long as I can here for at least another 27 minutes to kind of finalize this guy, everything I can on video. I might have to do some small adjustments off video just to figure out what parts I need so I could order them while I'm in Hawaii so I could get that going. So I did not look into getting everything to work here as far as this meshing error. So pretty much what I'm going to do on this video is I'm just going to kind of start moving stuff around so I could figure out what I can do as far as the being able to move this stuff now with the motor. So we kind of decided here that we're going to have two. We're going to have a 60. We're going to have an HGR 20 rail and then some HG20CA, HG20CA. Or we might have one of the long ones. Let's see. But we probably won't because we could actually decrease this. So we're gonna have the screw be like right here for the Z, and it's basically gonna be attached probably right to this guy or to this guy, probably behind here. So it's going to be attached here, so we probably don't need this other piece here because it's not really going to hold it up unless we have a rail there, because we have to let this guy slide, so this is probably not going to help too much with the rigidity of the piece. So we'll actually decrease this quite a bit. So we're probably going to do just barely have two of these guys, so I don't think we need the HA, which are the longer ones. This is 3.05, which makes it a lot better because these are way wide. 3.0 it said, so yeah, we could drop this down to 6 inches. 6 and an eighth. 6 and an eighth, no problem. And then what about from here over? About minimum of 1.935. Yeah, so we could drop it down to 6 inches, no problem. All right, so yeah, we need 1, 2, 3, 4 of these rails, HGR rails, and we need 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6 of these, plus 2 on here, 7, 8. Oh, and this rail as well. So it's going to stay really, really simple. So we're going to figure out right now what ball screws we could put on this guy. So let's go ahead. So that's there, that's there. So basically what I'm looking for now is slider, and then this is rigid. So I'm actually looking for this guy. The idea for right now temporarily, oh, not that. This then. Yeah, this one. There we go. So basically move this guy over arbitrarily, let's say. Okay, so now basically the screw is going to go in this area right here, and then this guy is going to be over here for so it's going to be kind of bolted, it's going to be kind of cantilevered over here, and then it's going to have a piece that goes over here and then goes here. So now, basically, the screw will fit down here. So let's go ahead and draw. And whether or not we actually CAD it right now is not that big of a deal. It's just kind of to have some sort of orientation of what will actually fit in here. Let's project this as well. So let's see what will fit. And project this. And project pretty much project everything. Doesn't even matter. Okay. Okay, so let's see. Obviously we can't have it, we don't want it to pass this point. So we want it to be, let's see here. This goes to this, and then obviously this goes to that. So that's basically the biggest it can be, and obviously it's gonna have to be smaller than that. So let's see what this is. Okay, so we're gonna have a 1-inch ball screw. Let's see what they have here. Let's see what they have on AliExpress. 1-inch ball screw. Okay, so it's in millimeters. So 1 inch is about, and that's another thing, probably needs to be supported. Ball screw. Keep it nice and stiff. This is 1605. Ball nut. Flexible couplings. I'm not too crazy on the flexible couplings because sometimes they cause a lot of issues. So this is nut size table. Alright, so this is 16 millimeters to inches. So what I'm guessing, it says 1605, so I'm guessing that means 16 millimeters in diameter. Okay, so it's less than 3/4 of an inch. So we need something a little bit bigger. What do we got? 1605. And I think the 5 is the pitch. $16 would be okay, because then we can move this guy. Oh, this guy's off of the piece there. So yeah, maybe an inch or bigger. 16 seems to be 3/4 of an inch. How big is that? Is that big enough? That's a pretty big ball screw. 3/4 of an inch would probably be okay. I mean, that's a big ball screw. And then obviously we're gonna probably go with NEMA 17s because again we just need 5 pounds of force at decent speeds. So yeah. Alright, so that guy. So let's delete this. Let's delete this. So let's look at 1605. So 1605 ball screw dimensions. Yeah, diameter 16. You might even put backlash nut, but it's basically just gonna hold it into the cut, and usually not that bad of a backlash on the ball nut. So, but yeah, it's 16 millimeters. So let's take a look at that 16 millimeters. Okay, it's a little small. They have a 20. .2005. What about a 20 millimeter ball screw? It's better. They have a 25 millimeter ball screw. 2505 or something? Yeah, 2505. Now we're getting bigger. Now we're starting to get into big dollar territory. So this is about, this one is, let's see, so 300 millimeters. 300 millimeters. Oops, 300. It's 11 inches. This is definitely not 11 inches here. Okay. Yeah, it's about $91 for that. But then again, we have two end blocks. Plus a place for the motor to go. A guide. So a guide to hold it. But probably not going to use that. We just kind of need the ball screw and the ball nut and the coupler. If I even be a rigid coupler, even just make the coupler just be a rigid coupler. It doesn't need to be a flexible coupler because we just got to get the alignment right. Alright, well, let's keep that in mind. We can kind of see there what that looks like. So now, the next piece is we're going to go inside and let's look at what it takes to put something right in between here to keep the flex out of this bar here. So let's go in and let's do a sketch, project this. Okay. So what's the biggest circle we could put in here? About a 1 inch. So it's very similar. So let's try if we have a, what is this, 25 millimeter. Can it fit? What's next biggest? You have a 30 millimeter? 30 millimeter ball screw. .3205 is the next size. 3205 ball screw. .32 millimeters. That's a big guy. Yeah, it's too big. So let's try 26 millimeter ball screw. Nope. So 25. What about 26? There's 25, there's one, 27. There's not one. 28 millimeters. Yeah, so it seems like 25 is pretty standard. What about 29? No. So yeah, it looks like 25 is pretty standard. Which, okay, so I mean that's basically, that's going to cost me another about $100 each. So there we go. So this is going to help stiffen this guy up. It's going to help stiffen this guy up. Ooh, but again, we need to make sure that that nut clears. But then again, the nut could be over here somewhere. The nut could be on top, kind of straddling this guy. And this guy could be really close. So let's see. See if it's got a. Let's have the nut. There it is. Oh, here are the standard sizes. 25, 25. Yeah, next up's 32, then 40, then yeah, 40, 20, 50, 63. So 25 is pretty standard, it looks like. 25.05.3. It's in Chinese. Oh. I don't know what these. Oh, this is diameter. Oh, and then pitch. And then I think this is actually pitch. I don't know what this 3 is. 40D1. So yeah, you can see here it's in Chinese here. A whole bunch of stuff's in Chinese, but so this is H1. So we could have it go this way to clear. And we're looking at a 25.05. $38.62. So we're looking at H1, which is the thinnest. It's 48 millimeters. That's big. Nope. Ain't gonna cut it unless I machine it down. I could do that. Machine it down a little bit because this is B. Is that B? Yeah, B. So the B clearance is 25.05. B clearance is 10. 10 what? 10 millimeter? No, that can't be right. What? Doesn't make any sense. Oops. Let's put it in here. Okay, then that's can't be B then. I don't know what that symbol is. Oh, D1, D2, and D3. Okay, so D2, which I think is pretty close to D1. Okay, it's 25.05. Yeah, they're about half a millimeter off, so it's about 40 millimeters. So D1, D2 is about 40. Oh, they're the same here. Then D3 is big. D3 is 62. So this is 40 millimeters. Yeah, it's not gonna fit. Now unless I bring this up. Obviously don't want to add anything else. So let's see. 16 millimeters, which is about 3/4 of an inch, which is not bad. We have a D3, D1, D2 of 28. So what if we use that? Oh yeah, that's small. It'll clear. Just barely. So we could do a 16 millimeter. But that's pretty small. So that's a 28 right there. Yeah, 28. So this is what the actual looks like. Let's see what the actual ball screw looks like. CA COA. I think that it's in kilonewtons. I'm sure that this will be able to take 4 pounds pushing it that way. And even probably this will take 4 pounds pushing down, so not too worried about it. This one obviously needs to hold down into the cut. while it's spinning. So I think that's going to be more force than this going back and forth. Same deal here. Because here we're not losing anything, so it's not really that big of a deal because of that. And down here, again, we would want it probably to fit in between these guys here. So basically, wait, what happened? What? Okay, so there and there. Obviously it needs to be lower than one of these, and I don't think it's the other one. Okay, they're just barely not lined up. So what can fit underneath here? And again, we need that guy to clear, so we're not going to look at the actual thing, we're going to look at D1 to clear. And then if we have to, we'll machine it all the way down to 2 bolts. But we need at least D1 to clear. So 1605 D1 is 28. So 28 millimeters. It's big. It is big. So the next, I mean, the smallest that they sell is the 12 millimeter, which has a 22 D1. Oops. So 22 millimeter. Alright, so we would have to put a foot. So we'll have to put some foot down here, but already we're maxed out pretty good on this here. And also, when I think about it, there's going to be a motor popping out here. So what are we at already? We're at 17 inches. And that's not even with a motor popping out. So what we might do is I'll probably have a bracket coming off the back here somewhere attached to this thing and have a motor down here. And then a pulley go across so I could reclaim some of that. Same deal over here. Instead of having the motor sit on this thing, I'll have the motor maybe on top here somewhere, sticking up, and then pulley down here so I don't have to lose floor space there. So I have another 3 inches. Some of it's going to be for the cable. So 3 inches down from here. Let's say if we had the cable, okay, so 3 inches. Yeah, we have a ways down. Well, it's actually 2.5 inches to fit to clear the table. But what about this? Where is this with respect to the table? Ooh. Yeah, so I think I'm going to get rid of that bottom piece of the rail. It's screwing with the clearance. It should just go up to the bottom of this. It's from the bottom of this to the top of the table. That's 5 inches. Because if that's the case, we can lower this down. There's less of a moment on here. Because again, we just need 3.5 inches here. A little bit over 3.5 inches. So once we get that, we should be okay. And I'll look at a few of the rotaries at Hawaii, so I can figure out which one we're probably going to use. Alright, so we have a pretty good idea. So we could run a 25 up here. We could run a 16 this way. We could run probably another 16 this way. We might just go all 16. We'll save some money and add a little bit more weight. And we'll run NEMA 17s because again, we're trying to go with as little force as possible, so it doesn't destroy this little 800 watt spindle. So 1 horsepower spindle that's running at really high RPM, but using a tiny little end mill. But again, we're still cutting steel, so we still have to hold it into the cut. So, but 16 millimeters should be fine. I mean, that's 3/4 of, I think, hardened steel. 3/4 of an inch is pretty big. That's like the size of your thumb, or my thumb at least. That should be okay. 25 millimeters. That's about an inch. That's a big ball screw. I think any bigger than that, you're basically getting to VMC size of a ball screw. So I think here 16 should be okay. So 16 here, 16 crossed, 16 down here. And we should be okay. And then again, we'll probably do the same deal with belts. Run belt here, and then we'll decrease it for torque. But again, remember, we're moving pretty quickly. We're moving like 50 inches per minute. So we might do 16 to a 16 here, and then run belt. And then here, same deal. We don't want to lose anything on top. We want to have as much clearance. So we'll have the belt, we'll have the motor on the backside come up over here and then go here. And then this guy, we're going to drop 1.5 inches here so that these just fit across. And then we'll have probably 130 pounds there with the NEMA 17s, with the pulley system, etc., etc. Alright guys, we kind of have a good idea of what we're doing here, so I'm going to make these decisions, unfortunately probably off camera, and then I'll kind of explain what I did. But here you kind of get an idea of what goes into these types of decisions. It's just kind of checking clearance, looking at the spec sheet, making sure things are going to fit. How are we going to conserve room by making things belt driven, increasing torque, whatever. And being able to work around what we have and making sure that this guy stays as rigid as possible, and that includes adding weight, but also adding weight and rigidity at the same time, not just adding weight for no reason. So either motors or with other support systems, which this looks really good. And then having acrylic here coming up, acrylic here coming up, and so we could shoot mist, so we could shoot a fog buster and keep the cut lubricated, so lower our forces, and hopefully if this guy's rigid enough, have low vibrations. So if not, we'll put it in a box. I don't know how I would go about doing that. I would probably put it in a different shelf. So I have another shelf that this guy will also fit in, and then put a Lazy Susan on that, and then have it dampered, and then take it out, pull it out, put the pieces in, put it back in. So this might have to go in that cubby, but that relieves some more space. And then basically you put it in there, and then I put a door to seal up that chamber there to keep all the noise in. So because that's going to be extremely noisy. It's going to be about as noisy as the laser. Before I quiet down the pump, probably going to put the air pump and all the water and everything on the inside of the machine, so it should stay relatively quiet. Same deal with this one. Fog buster here, I'm going to probably coat the inside of this case so that it stays waterproof on the inside there, and then have the acrylic and a Lazy Susan. You pull the Lazy Susan out, and then you just do what you need to do with this guy. I'm not the Lazy Susan. Just pull out a drawer. It's on a drawer slide because it's only 100 pounds. Pull it on a drawer slide. Set down a little stand, a little foot stand, and then go and take your parts off. Clean it off. Clean all the fluid off, and then yeah, and then put a door on it so it's nice and quiet in there when it's doing its machining, and then I don't have to worry about the clearances too much. And I think that it's actually it's probably wider than this. I don't know about depth. I'll have to look at it, but I do have a little cabinet that this guy could go into if the table doesn't work out, and it's extremely loud, which probably will be. Because I machined aluminum on a Shopbot Buddy and it howls like crazy. So if that's the case, then we could put it on the inside of that cabinet and just put a door on the face. It's got a nice little faceboard on it, and zip a few holes and put a door on it. Quiet it all up. And we have a nice little quiet box. Run it in there. Nice little enclosure. And then when you're done, you take the enclosure off, pull the cabinet out, and you're good to go. And then have the laptop on the outside with a wire going in, right next to the laser. So it'd be the router would be inside, then the laser, then the printers or whatever, and then whatever else I need. And then this will save some precious worktop space, because the laser won't fit in any of those cabinets because it's too long. It's like 30 something inches long, and I don't think it'll fit in that cabinet. And plus, so you have to get exhaust and everything out. Here you just have to get electrical in through a side, and also wire control. And then this is just going to use a gerbil, or I might buy a Mach 3 board or something on it, but probably just use gerbil. And so that's kind of the idea. So we'll see you. We get work on the tabletop. If not, we'll put it in that drawer, and then just have it run in there. Because again, Ava's, my 1-year-old niece is running around, and also she sleeps upstairs, so don't want it to vibrate through the floor and her to wake up when this thing's running. So that way, I can produce at least one a day. Run this guy once a day with Fogbuster and get some parts made with it. Alright, so this has been Steven from the Green Engineers and Legit Tech Tutorials. I thank you guys for watching. So I'm not going to be here for the next week, so I'll probably just, because I've been saying that I'm going to do one per day, I'll probably just dump the rest of the files on. I have one more big video that's dumping right now on my car channel. I didn't do that yesterday or this morning, so I'm catching up with that, and then I'll see if I could dump each of these. And if not, I'll have to do it some other way, or just wait till I get back. Alright, I'll catch you guys next one. Thanks for watching. Take it easy. Peace.